Imagine being 250 miles above Earth, completely dependent on machines to create the air you breathe. For decades, this has been one of space exploration's most dangerous challenges. The International Space Station uses massive, power-hungry machinery to split water into oxygen and hydrogen. These systems are so heavy and energy-intensive that they're completely impractical for missions to Mars. But what if I told you that scientists just discovered a solution using nothing more than a simple magnet you could buy at any hardware store? Here's the problem. On Earth, oxygen bubbles naturally float to the surface when you split water using electricity. But in the weightlessness of space, the bubbles refuse to float. They stick to the electrodes like glue, creating a barrier that makes the process inefficient. Current solutions require centrifuges, mechanical separators, and consume enormous amounts of power. Every kilogram and every watt is precious in space. Enter an international team from the University of Warwick, SpaceVrse in Bremen, and Georgia Tech. They've been working on this problem for 4 years. It started with Alvaro Romero Calvo at Georgia Tech, who had a crazy idea in 2022. What if we could use magnetic forces to move these stubborn bubbles? The secret lies in how water and electrical currents interact with magnetic fields. When you pass electricity through water in the presence of a magnet, the magnetic forces can guide oxygen bubbles to collection points or spin them away, essentially creating an artificial centrifuge effect. Professor Katarina Brinkert from SpaceVrse explains, "We don't need centrifuges or mechanical moving parts. We don't even need additional power." To test this theory, the team used Bremen's Drop Tower, a 146-meter facility that creates microgravity conditions for crucial seconds. By dropping their experimental setup, they could simulate space conditions and observe how the magnetic system performed in zero gravity. The results were stunning. Oxygen collection efficiency increased by up to 240% compared to traditional methods. Think about what this means. Instead of carrying tons of heavy equipment, future Mars missions could use a handful of small magnets. No moving parts means fewer things to break. No extra power requirements means more energy for other critical systems. This isn't just about getting to Mars, it's about surviving there long-term with reliable, low-maintenance systems. This breakthrough opens the door to sustainable human exploration beyond Earth. Sometimes the most elegant solutions are the simplest ones. A $5 magnet might be the key to humanity's future among the stars. What other simple solutions are hiding in plain sight? The next breakthrough in space exploration might be sitting on your refrigerator door right now.